The night the universe spoke. On a warm summer night in 1977, while most of the United States slept under a quiet August sky, a machine in Ohio, an enormous fixed radio telescope, known simply as the Big Ear, was listening to the universe. It had been listening for years, drifting through static, cosmic background noise, the gentle radio hiss of stars and galaxies far away. It was a night no different from countless others in the history of radio astronomy. The Earth rotated silently, the dish remained motionless, and the signals of the cosmos continued their eternal symphony. Most nights provided nothing but the gentle hum of cosmic radiation, the familiar silence of space. But this night was different. Inside that quiet research facility, a signal appeared. Not a random burst, not a glitch, not the typical noise astronomers tirelessly filtered through. No, this was something else, something sharp, strong, precise, something that made sense in a way the universe rarely does. It was a signal that lasted 72 seconds, the exact amount of time the Big Ear could observe any point in the sky as the Earth's rotation swept its beam across the heavens. And in that brief moment, humanity witnessed something extraordinary. A young astronomer named Jerry Emmon, volunteering for SETI, the search for extraterrestrial intelligence, came across the strange printout days later. It was just a run of numbers and letters, the usual output format. But one sequence stood out like a flare in the dark. 6EQJ5. This was not noise. This was powerful, unusual, structured. Without thinking, Emmon grabbed a red pen and circled the sequence, and next to it, he wrote the word that would echo through scientific history. Wow! It wasn't the data alone that created the mystery. It was everything around it, the frequency, the precision, the intensity, and the fact that nothing like it had ever been heard again. This is the story of the WOW signal. A story of chance, science, mystery, hope, and the terrifying possibility that for one single moment, the universe may have whispered back. The Big Ear listens. The Big Ear radio telescope was a strange machine. It didn't look like the massive, round satellite dishes most people imagine. Instead, it stretched across the ground, two huge reflectors facing each other, one flat, one curved, both working together like a giant cosmic net. It was enormous, the size of 3 football fields laid end to end. The Big Ear wasn't designed for pretty pictures or optical beauty. It was built for numbers, radio waves, electromagnetic whispers drifting across the cosmos. And it did one thing exceptionally well. It listened, endlessly, patiently. By 1977, the Big Ear had already spent years mapping radio sources across the sky. Its data flowed into computers that converted signals into alphanumeric codes. Each character, sometimes a number, sometimes a letter, represented the strength of the detected radio source at a particular moment. For most of its career, the data was beautifully boring. But space has a way of hiding its most extraordinary secrets in the margins of ordinary nights. The hydrogen line. The WOW signal didn't just appear anywhere on the spectrum. It arrived at 1420.4556 megahertz, a frequency astronomers call the hydrogen line. Hydrogen is the most abundant element in the universe, and because of a quantum mechanical property called spin-flip transition, neutral hydrogen emits radio waves at 1420 megahertz. This frequency travels across space with minimal interference. For decades, SETI researchers believed that any advanced civilization trying to communicate across star systems would likely choose this frequency. Why? Because it's universal. It's fundamental. Any intelligent species studying physics would know about it. So for the wow signal to appear exactly at or extremely close to the hydrogen line was not just interesting, it was electrifying. Astronomers understood the implication instantly. If someone out there wanted to be heard, this was the most logical frequency they would use. The cosmos has countless random noises, countless bursts, flares, pulses, and interference, but virtually none appear so cleanly at the hydrogen frequency. Whatever created the wow signal knew the universe very, very well.
The 6EQJ5 anomaly. The format of Big Ear's data looks confusing at first glance. Each character corresponds to a strength level. 1 to 9 represent increasing intensity. Then letters continue the scale. A equals 10, B equals 11, C equals 12, and so on. The sequence 6EQJ5 showed an incredible rise and fall in signal strength. 6 is already moderate. E is strong. Q is extremely strong. U is stronger still. J means incredibly high intensity, followed by another 5, tapering off as the telescope beam moved away. This is exactly what one would expect from a real point source in space. Natural signals fluctuate chaotically. Instrument glitches show irregularity. But this was smooth, symmetrical, shaped like a perfect cosmic bell curve. The signal behaved like it was real, coming from a fixed point far out in space. Not bouncing off objects, not distorted, not fading randomly. Clean, sharp, structured. A whisper with intent. Where did it come from? When the coordinates were traced, the signal was found to originate from the direction of Sagittarius, near the star group Chi Sagittarius. This region is dense with stars, nebulae, and potential planetary systems. But there's a catch. The Big Ear had 2 feed horns, 2 listening points. When a real signal passes overhead, the telescope hears it twice, once in each horn, separated by a few minutes. The wow signal appeared in only one. That suggested one of 2 things. The signal was extremely narrow, so precise that only one horn caught it. Or it was a one-time burst, lasting just long enough for the first horn, but gone before reaching the second. Either possibility was astonishing. A narrow beam suggests technology. A one-time burst suggests something powerful and rare. For decades, astronomers have returned to the same coordinates, searching, listening, hoping. But nothing ever came again. No faint repetition, no weaker echo, not even static resembling it. Just silence. The universe spoke once, and then went quiet. Nonsense explanations fail. Over the years, skeptics offered explanations. Some were clever, some were desperate. But all eventually collapsed. Satellite interference? There were none in that frequency in 1977. Military signals? Classified or not, they don't match the signal's shape, frequency, or intensity. Natural hydrogen clouds? Hydrogen clouds emit broad, diffuse noise, not sharp 72-second bursts. Airplanes? Reflections? Signals bouncing off debris? Tested, simulated, all inconsistent. In 2016, a new theory claimed comets might emit hydrogen at the right frequency. But detailed observations showed their emissions were far too weak and not even correctly positioned at the time. Every attempt to explain away the wow signal failed under scientific scrutiny. The universe leaves fingerprints. This one had no match. A message or a mistake. The most thrilling and the most unsettling interpretation remains the simplest. It might have been a message. Not necessarily intentional, not necessarily directed at Earth, perhaps just a technological emission from a distant civilization sweeping past us like a lighthouse beam across a dark ocean. A civilization we may never meet. A signal we may never hear again. The wow signal became a symbol of possibility, a reminder that we are not just observers in the cosmos, but potential participants in a much larger conversation.
The night the universe spoke. The discovery of 6EQUJ5. August 15th, 1977. A warm summer night in Ohio. A night that began like thousands of others at the Ohio State University Radio Observatory. Quiet, uneventful, routine. No one present at the observatory that night knew that the universe was about to whisper one of its strangest secrets. A whisper that would be captured, printed, circled in red ink, and then debated for nearly half a century. This is the story of the night the wow signal was born. Chapter 1. The Hum of the Machine. Inside the control room, fluorescent lights buzzed softly. Computers the size of refrigerators blinked with dull red LEDs. Paper printers rattled endlessly as they spat out streams of coded data. 0001, 0100, 002, 0000. It was monotonous, hypnotic, mechanical. SETI volunteers monitored panels of switches, knobs, dials, and analog meters. The technology of a world before digital screens, before laptops, before the internet. The Big Ear telescope outside was silent but alive. It was listening, always listening, to the sky above. Every second, cosmic radio waves that had traveled light years across the universe were being gathered, filtered, analyzed, and printed as numbers and letters. Most nights, nothing happened. On this night, something did. Chapter 2. The Sky Position. At approximately 22:16 local time, Big Ear's gaze swept across a region near the constellation Sagittarius, close to a group of stars known as Chi Sagittarii. This region is densely packed with stars. It is close to the Milky Way's center, rich in gas, dust, energy, activity, and unknown phenomena. But among all that cosmic noise, something unexpected emerged. A signal so strong, so sharp, so unusually precise, that nothing else Big Ear had ever seen came close.
On Big Ear's printout, the signal began like a faint murmur. 6, a higher than normal reading. Then it grew. E, intensity climbing. Then Q, stronger still. Then U, unmistakably powerful. Then the peak, J, a surge, the highest letter used by the coding system. And then finally, 5, a decline, back into normal cosmic background. The entire event lasted 72 seconds, exactly the amount of time it would take for a stationary celestial source to drift across Big Ear's detection beam. No drifting frequency, no modulation, no spread, no noise. It was as if something emitted a pure, concentrated, laser-like beam of radio energy straight at Earth. The next day, the printouts were piled on a table. Thousands of lines of dull characters, the data of yet another night. Then SETI volunteer Jerry R. Ettman, a man deeply familiar with the monotony of these patterns, sat down to examine the sheets. As he scanned the columns, something caught his eye. 6EQJ5. 6 characters that should not exist in that order. 6 characters that implied a signal far above the cosmic background. 6 characters that stood out like a lightning bolt in a clear sky. Ettman froze. He stared at the alphanumeric string. His brain processed the implications. And then he did something legendary. He grabbed a red pen, circled the sequence, and wrote one word in the margin. Wow. A single, spontaneous reaction. A human moment. A moment that named a mystery. That red circle has since become one of the most iconic images in SETI history.
A whisper from the unknown. The more Ehrman studied the pattern, the stranger it became. The signal was narrowband, exceptionally strong, in a protected frequency, 1420 MHz, astronomically clean, perfectly shaped like a real celestial drift, not repeated before or after. It behaved exactly as an extraterrestrial transmission should, and nothing like any known natural phenomenon. Even Ehrman himself later said it was the most significant thing we had seen, but we could never prove what it was. The signal appeared once, only once. If it was a message, it was a whisper sent across the stars and never heard again. The frequency of life. One detail stands above all others: the signal's frequency. 1420.456 MHz, a frequency near the 21-centimeter hydrogen line, the most important frequency in all of astronomy. Hydrogen is the most abundant element in the universe. Its 21-centimeter emission line is a cosmic standard, a universal thing for advanced civilizations. SETI scientists have long predicted that if aliens ever tried to get our attention, they would use this frequency. The wow signal was exactly where it should have been. Coincidence? Intentional choice? Nature's accident? Or a deliberate broadcast? We still don't know. Chapter 7. The experts meet a paradox. As soon as the signal was revealed, astronomers rushed to replicate it. Big Ear listened again. Other telescopes around the world were directed at the same coordinates. The region was scanned repeatedly for years. Nothing. No repeat signal. No trace. A perfect paradox emerged. Too structured to be natural. Too unique to be confirmed. Too perfect to dismiss. Too rare to understand. Science needs repetition, but the wow signal offered none. It was a cosmic ghost, a one-time event, a fingerprint with no hand, a voice with no speaker.
The moment SETI changed forever. Before the wow signal, SETI was a fringe pursuit, a noble but obscure scientific effort. After the wow signal, everything changed. The signal electrified the scientific community. Journalists wrote articles. Radio astronomers restructured their projects. Funding proposals multiplied. Public interest exploded. The wow signal proved something profound, not that aliens exist, but that the universe is capable of surprising us in ways we are not prepared for.
Wow signal. The impossible message. Science breaks down the wow signal. For decades, scientists around the world have tried to break the wow signal apart, to examine its structure, to dissect its frequency, to understand its power, its shape, its behavior. Every attempt to analyze the signal leads to the same conclusion. It should not exist. Natural cosmic processes do not behave this way. Human-made interference does not behave this way. Instrument errors do not behave this way. The wow signal sits in the center of a scientific void where every known explanation collapses. This is the scientific anatomy of an anomaly. The shape of the signal, a cosmic fingerprint. The wow signal isn't famous only because it was strong. It is famous because of its perfect mathematical structure. The 6EQUJ5 sequence does not represent random characters. It is a precise encoding of intensity levels measured over 12-second intervals. Let's break it down. 6 equals moderately above background. E equals stronger. Q equals rising steeply. U equals high. J equals peak. 5 equals falling, returning to background. When plotted on a graph, the signal forms a perfect bell-shaped curve, a Gaussian profile. This matters. A Gaussian curve is exactly what you would expect from a fixed-location transmitter in space as Earth's rotation brings the telescope's beam across it. Natural sources rarely produce this signature. Human interference almost never does. And yet, the wow signal is textbook perfect. It is the cosmic equivalent of a laser pointer sweeping across a sensor. Accidental? Unlikely. Extraordinary? Absolutely. The power. An energy burst from the unknown. The wow signal was not just neatly shaped, it was surprisingly strong. Even accounting for the sensitivity of Big Ear, the signal was estimated to be 30 times stronger than the typical cosmic background at that frequency. To achieve this power level, a transmitter, if it was a transmitter, would have to be incredibly precise. Depending on the assumed distance, the required energy output would vary. If the source was within our galaxy, a medium-power directional antenna would be enough. If the source was hundreds or thousands of light-years away, the power required becomes astronomical, comparable to the output of a small star, but only if beamed directly at Earth.
This is the key. The signal was narrowband. Narrowband signals require intention. They do not occur naturally at such strengths. The universe emits static, noise, bursts, pulses, but a clean, narrow, powerful frequency spike? That implies engineering, design, purpose. The frequency of intelligence. The wow signal's frequency is perhaps its most important feature. 1420.456 megahertz, right next to the hydrogen line, 1420.4057177 megahertz. Hydrogen's 21-centimeter line is universal. It is the cosmic baseline. Every star, every galaxy, every nebula contains hydrogen. This frequency is so fundamental that it penetrates interstellar dust, it travels far with minimal attenuation, it is easy to generate and detect with minimal technology. For these reasons, SETI scientists long ago proposed, if an intelligent species wants to send a signal across the galaxy, they will likely use the hydrogen line. The wow signal was exactly there, not near it, not in the same general band, right on top of the cosmic calling card. This is like finding a message written in the most universal language in the universe. Coincidence? It would be one of the most extreme coincidences in scientific history. The protected band mystery. Another factor deepens the mystery. The WOW signal occurred within a protected frequency band. These are frequencies where terrestrial transmitters are legally forbidden to operate because they are reserved exclusively for radio astronomy. This means no airport radar, no TV broadcast, no military signal, no satellite beacon, no phone tower, no amateur radio, no Earth-based transmitter of any legal type could have created the WOW signal. Furthermore, even illegal or malfunctioning devices almost never transmit in narrowband signals perfectly aligned to the hydrogen line. The idea that the WOW signal was just interference becomes incredibly unrealistic once the protected frequency band is considered. The single beam paradox. The Big Ear telescope used two beams, separated by a small angle. If a real sky signal passed overhead, both beams should detect it, one after the other. The WOW signal appeared in only one of them. This created a paradox. If the source were too narrow, it might pass through only one beam, which is consistent with an artificial transmitter. If the source were too broad, it should appear in both, which it didn't. If the source were terrestrial, it should spill into both, which it didn't. If the source were an instrument glitch, it should appear in random places, which it didn't. The single beam detection suggests a real point source in space, but so narrow that it mimicked the signature expected from a directed broadcast.
The drift rate, a signal from the stars. The WOW signal exhibited a perfect Doppler drift profile, consistent with a signal emitted from a source fixed in space as Earth rotated. What does this mean? If a transmitter is stationary relative to Earth, the frequency doesn't change. If a transmitter is in motion, such as a satellite, the frequency drifts rapidly. The WOW signal did not drift like a satellite, did not wobble like a plane, did not shift like a meteor, did not fluctuate like atmospheric noise. It behaved exactly like a distant astronomical source. But it was too narrow, too sharp, too strong to be natural. This is why astronomers call the WOW signal an unnatural signal with natural mechanics. A contradiction, a paradox, a nightmare for skeptics, and a dream for SETI. Why it could not repeat. Perhaps the most fascinating feature of the WOW signal is that it never occurred again. Thousands of hours of follow-up observations found nothing. Big Ear searched, Arecibo searched, the Very Large Array searched. Other observatories searched, but the sky remained silent. There are several possibilities. Possibility 1. It was a deliberate one-time beacon. A civilization may send periodic test signals or rotating beams. Possibility 2. The transmitter is intermittent. It may broadcast at extremely long intervals. Possibility 3. The source itself vanished. A catastrophic event, like the destruction of a star system, could explain a burst. Possibility 4. Earth simply wasn't aligned again. A perfectly narrow beam could miss Earth by light years if the angle shifts by even fractions of a degree. Many stars with habitable zone planets rotate rapidly. A beam from such a planet could sweep across space like a lighthouse, hitting Earth only once in centuries.
The unresolved problem. Nothing fits. After decades of research, everything remains contradictory. Too strong to be natural. Too narrow to be accidental. Too clean to be interference. Too precise to be random. Too temporary to be confirmed. Too perfect to be ignored. This is why scientists call the WOW signal the most intriguing radio signal ever detected from space. Its structure is flawless. Its timing is perfect. Its frequency is meaningful. Its behavior matches a celestial transmitter. But without repetition, it can never be proven. The WOW signal is suspended between science and mystery. A whisper from the unknown. A voice from the void. A message with no sender. Theories, debates, and the unexplained. Science versus mystery. The WOW signal is as much a story about human imagination as it is about radio waves. When the sequence 6EQJU5 appeared on Big Ear's printout, scientists faced a paradox. A signal that appeared engineered, yet could not be traced to any known source. Over the decades, multiple explanations were proposed, some plausible, others far-fetched. In every case, however, the WOW signal defied certainty. Chapter 1. Comets and Hydrogen Hypotheses. 2016, a team of astronomers proposed a new idea. Perhaps comets could have caused the WOW signal. The theory argued comets 266P Christensen and P-2008Y2 Gibbs might have passed through the telescope's field of view. Hydrogen emissions from their tails could explain the 1420 MHz signal. At first, this seemed promising. Comets are abundant in hydrogen, and their movement could produce a fleeting signal. But further analysis shattered the hypothesis. The comets were not in the exact location of the WOW signal. The hydrogen tails were too diffuse to produce the sharp 72-second Gaussian signal. There was no single beam detection explanation. In short, the comet theory could not reproduce the precise characteristics of 6EQJU5. The scientific community largely rejected it, yet it briefly captured headlines, illustrating how even decades later the WOW signal inspires bold speculation. Chapter 2. Terrestrial Interference, a False Alarm? Could the WOW signal have been human-made? Big Ear was isolated but not immune. Scientists considered military radars, aircraft transmissions, satellite interface, accidental reflections. Every possibility was analyzed in painstaking detail. Military radar, frequencies did not match, timing was inconsistent. Satellites. In 1977, no satellites operated in that band. Reflections. The precise Gaussian shape of the signal made this nearly impossible. The conclusion was terrestrial interference could not explain the signal. The signal's location, shape, frequency, and duration were all inconsistent with anything Earth-based. Chapter 3. Instrumental Errors. Can technology lie? Could Big Ear itself have created the signal? Astronomers considered printer glitches, receiver malfunctions, power surges, cosmic ray hits on the electronics. Every system was checked. Every error scenario was modeled. Result: none matched 6EQJU5. If the telescope produced the signal itself, it would have done so randomly, and Big Ear's record shows that no other signal like this ever occurred. It was unique. It was singular. It was real.
The legacy of 6EQJ5, science, philosophy, and humanity's place in the universe. Since the moment Jerry Emmons circled 6EQJ5 in red ink, the WOW signal has remained one of the most profound and enduring mysteries in astronomy. Over decades, scientists, engineers, philosophers, and enthusiasts have grappled with its meaning, its origin, and its implications for life beyond Earth. This final chapter reflects on everything the WOW signal represents, a signal that continues to echo through science and culture. Chapter 1. Summary of the Mystery. Let us recap what we know. Detected on August 15, 1977, at the Ohio State University Radio Observatory, Big Ear. Lasted exactly 72 seconds. Appeared as a narrowband Gaussian-shaped signal at 1420.456 MHz near the hydrogen line. Captured in a single beam only, a cosmic fingerprint of unparalleled precision. Designated 6EQJ5, famously circled with a red pen and annotated with the word WOW. Attempts to identify natural, terrestrial, or instrumental causes failed. No repeat signal has ever been detected, despite decades of targeted observation. The WOW signal stands alone, a singular event bridging science, technology, and imagination. Chapter 2. Scientific Significance. The WOW signal has changed SETI and astronomy. Guiding observation strategies. Demonstrated the need for continuous global monitoring. Inspired the design of narrowband detection algorithms. Technological advancement. Stimulated improvements in digital signal processing, machine learning, and telescope coordination. Evidence of possibility. Proved that the universe could produce detectable engineered signals. Provided a benchmark for the search for extraterrestrial intelligence. Its scientific importance lies not only in what it was, but in how it shaped future research.
Chapter 3. Philosophical and Cultural Impact. The WOW signal also transformed our perspective. Philosophically, it reminds humanity that we are part of a larger cosmic community, potentially within reach of other intelligences. Culturally, inspired books, films, and media exploring first contact. Educationally, serves as a case study in probability, physics, and critical thinking. The red-circled WOW is now iconic, a symbol of curiosity, wonder, and the eternal human desire to listen beyond ourselves. Chapter 4. Future Implications. Looking forward, the WOW signal continues to guide humanity's exploration. Next-generation observatories aim to detect signals far more subtle and distant. Artificial intelligence scans trillions of data points in real time, inspired by the uniqueness of 6EQJ5. Global SETI cooperation ensures that if a similar signal reappears, it will not go unnoticed. The WOW signal teaches patience. Intelligence may communicate in ways that challenge our technology and understanding. It also reminds us, even a fleeting whisper from the stars can reshape human ambition. Chapter 5. The Lasting Legacy of 6EQJ5. The WOW signal's legacy is multifaceted. A scientific benchmark. A standard for evaluating unusual cosmic phenomena. A philosophical challenge. A question mark about life, intelligence, and our place in the universe. A cultural symbol. A moment when humanity briefly touched the unknown. Even though its source remains unconfirmed, its influence is undeniable. It represents the hope, the mystery, and the infinite curiosity that drive human exploration. Chapter 6. Final Reflections. The WOW signal is not just a radio anomaly. It is a message without a sender, a voice without a visible speaker. It challenges our scientific rigor, stimulates our imagination, and compels us to listen. It demonstrates that the universe can surprise us in ways we are not prepared for, and that even a single 72-second signal can inspire decades of inquiry, technology, and wonder.
As humanity continues to gaze at the stars, the spirit of 6EQJ5 endures. Listen carefully. Observe continuously. Wonder endlessly. The WOW signal is a reminder that we are explorers, not only of space, but of the infinite possibilities that lie beyond our comprehension.
Deep signal analysis, physics, evolution, and interstellar strategies. The WOW signal continues to challenge scientists because it exists at the intersection of observable physics, potential intelligence, and cosmic uncertainty. Understanding its possible origins requires a deep dive into signal propagation, evolutionary communication strategies, and advanced interstellar physics. Chapter 1: Signal Propagation and Interstellar Medium. For a signal to travel hundreds of light-years and retain a narrow-band Gaussian profile, several factors must be considered. Interstellar medium, ISM, consists of ionized gas, neutral hydrogen, and cosmic dust. It causes dispersion and scattering of electromagnetic waves. Hydrogen line advantage. At 1420 MHz, the hydrogen line penetrates ISM efficiently. Minimal absorption ensures the signal maintains clarity over long distances. Signal degradation. Cosmic noise, Doppler shifts, and Earth's rotation slightly affect frequency. The WOW signal retained remarkable integrity, implying a strong, highly directional source. These factors suggest the transmitter was carefully engineered to maximize detectability. Chapter 2: Energy and Directional Requirements. Modeling the WOW signal's energy. Galactic source, approximately 200 to 300 light-years. It requires megawatt-level directional transmission. Distant galaxy, more than 1,000 light-years. It requires power comparable to a small star, but if beam is tightly focused, feasible. Beam width and alignment. Only a few arc minutes wide. This explains why it appeared in one beam of Big Ear and never repeated. These calculations indicate intentional engineering, consistent with a civilization aware of interstellar communication challenges. Chapter 3: Evolutionary Communication Strategies. If the source was intelligent, its civilization likely evolved interstellar messaging protocols. Targeting potentially habitable systems, focuses on stars with planets in the habitable zone. Narrow beams maximize energy efficiency. Intermittent beacons. The signals may sweep across multiple systems. Duration could be brief to conserve energy. Universal frequencies. Hydrogen line acts as a cosmic universal language. It simplifies detection by civilizations with basic radio astronomy. Signal redundancy. Repeat transmissions could be centuries apart. It encourages civilizations to maintain long-term astronomical observatories. This framework aligns with SETI's theoretical models for detecting extraterrestrial intelligence. Chapter 4: Theoretical Technologies. Scientists speculate on technologies capable of producing 6EQJU5. High-gain radio antennas, large parabolic dishes with precise beam control. Optical lasers. Could produce narrow pulses detectable at vast distances. Hybrid electromagnetic systems. Combine radio and optical transmissions for multi-channel detection. Planetary-scale transmitters. Advanced civilizations may construct megascale arrays, directing energy with unprecedented precision. The WOW signal's properties are consistent with technologies beyond our current capabilities, yet physically plausible.
Chapter 5: Doppler and Motion Analysis. The signal exhibited a Doppler drift. matches a celestial source moving relative to Earth's rotation, not a satellite or aircraft. The precise profile allows back calculation of beam trajectory. Modeling suggests the transmitter could be stationary relative to its star system, enhancing efficiency. The drift analysis reinforces the signal's authenticity and cosmic origin, rather than being a terrestrial artifact. Chapter 6. Why the signal may be unique. Several factors contribute to its one-time appearance. Extremely narrow beam width. Earth may rarely intersect it. Short duration sweeps. Only a brief alignment produces detection. Intermittent transmission intervals. Could repeat every centuries. Technological or physical limitations. The source may no longer exist or have moved. This uniqueness has made 6EQJU5 a benchmark in anomaly detection, shaping SETI protocols worldwide.
Advanced technologies and future scenarios. The WOW signal may have lasted just 72 seconds, yet it continues to fuel scientific imagination. If it was an artificial signal, what kind of technology could have produced it? What kind of evolutionary path might the transmitting civilization have followed? And how does humanity prepare for a possible recurrence? Chapter 1. Evolutionary Scenarios of Extraterrestrial Civilizations. Assuming the WOW signal originated from an intelligent source, the civilization must have mastered highly precise electromagnetic transmissions. They may have developed planetary scale coordination to produce directional signals. Their evolution might have favored long-term technological stability, allowing for interstellar messaging. SETI theorists propose several evolutionary possibilities. Single-planet civilizations. Limited energy resources. Likely to use narrowband, highly directional transmissions. Multi-planet or star-hopping civilizations. Greater energy and mobility. Potential for galactic-scale communication networks. Post-biological intelligence. Machine-based intelligence capable of perfect precision. Could maintain consistent, repeatable signaling across millennia. These scenarios help scientists model expected signal strength, duration, and frequency, informing observational strategies. Chapter 2. Radios, lasers, and beacons. The WOW signal raises the question, what physical technology might produce such a transmission? Radio beacons. Most plausible scenario for 1977 observations. Narrowband, directional, long range. Energy efficient when transmitted along the hydrogen line. Optical or laser beacons. Could produce intense, narrowly focused pulses. Detectable with advanced photometric instruments. Unlikely in 1977 due to telescope limitations, but relevant today. Hybrid technologies. Combining radio and optical emissions for redundancy. Sophisticated civilizations may employ multiple channels to increase detectability. The WOW signal's precision suggests a purposeful engineered source rather than a natural phenomenon.
Implications for humanity. The WOW signal challenges humanity to consider: how should we respond if a repeat occurs? Should we broadcast a reply or continue listening silently? How would we interpret a signal without context, language, or intent? SETI encourages a cautious approach. The focus remains on observation, data collection, and verification. The WOW signal is a reminder that cosmic messages may be brief, enigmatic, and difficult to interpret, but no less significant for their potential meaning. Chapter 6. Long-term preparation. To prepare for potential future signals, humanity is investing in next-generation telescopes with higher sensitivity, distributed networks for global coverage, machine learning algorithms for rare event detection, public engagement programs to educate about extraterrestrial research. The WOW signal is a guiding example. A single anomaly can redefine scientific priorities and inspire generations. Chapter 7. Conclusion: The Unending Search. The WOW signal, though brief and unique, continues to resonate. It proves that interstellar communication is possible. It demonstrates the importance of precision, observation, and patience. It reminds humanity that the universe is vast, mysterious, and potentially inhabited. As SETI and future missions advance, the spirit of 6EQJ5 lives on, a call to listen, to search, and to wonder.
Deep signal analysis, physics, evolution, and interstellar strategies. The WOW signal continues to challenge scientists because it exists at the intersection of observable physics, potential intelligence, and cosmic uncertainty. Understanding its possible origins requires a deep dive into signal propagation, evolutionary communication strategies, and advanced interstellar physics.
Evolutionary communication strategies. If the source was intelligent, its civilization likely evolved interstellar messaging protocols. Targeting potentially habitable systems. Focuses on stars with planets in the habitable zone. Narrow beams maximize energy efficiency. Intermittent beacons. Signals may sweep across multiple systems. Duration could be brief to conserve energy. Universal frequencies. Hydrogen line acts as a cosmic universal language. Simplifies detection by civilizations with basic radio astronomy. Signal redundancy. Repeat transmissions could be centuries apart. Encourages civilizations to maintain long-term astronomical observatories. This framework aligns with SETI's theoretical models for detecting extraterrestrial intelligence. Chapter 4. Theoretical Technologies. Scientists speculate on technologies capable of producing 6EQUJ, high-gain radio antennas, large parabolic dishes with precise beam control, optical lasers, could produce narrow pulses detectable at vast distances, hybrid electromagnetic systems, combine radio and optical transmissions for multi-channel detection, planetary scale transmitters. Advanced civilizations may construct mega-scale arrays, directing energy with unprecedented precision. The WOW signal's properties are consistent with technologies beyond our current capabilities, yet physically plausible.
Doppler and motion analysis. The signal exhibited a Doppler drift, matches a celestial source moving relative to Earth's rotation, not a satellite or aircraft. The precise profile allows back calculation of beam trajectory. Modeling suggests the transmitter could be stationary relative to its star system, enhancing efficiency. The drift analysis reinforces the signal's authenticity and cosmic origin rather than being a terrestrial artifact. Chapter 6. Why the signal may be unique. Several factors contribute to its one-time appearance. Extremely narrow beam width. Earth may rarely intersect it. Short duration sweeps. Only a brief alignment produces detection. Intermittent transmission intervals could repeat every centuries. Technological or physical limitations. Source may no longer exist or have moved. This uniqueness has made 6EQJ5 a benchmark in anomaly detection, shaping SETI protocols worldwide. Simulations, follow-up searches, and technological impact. The WOW signal, though fleeting, has inspired generations of astronomers to simulate, replicate, and search for similar cosmic anomalies. Modern technology allows scientists to explore the signal in ways unimaginable in 1977. Chapter 1. Modern Simulations. Today, astronomers use advanced telescopes and computer models to replicate the WOW signal. The Allen Telescope Array, ATA, simulates narrowband transmissions across hundreds of nearby stars. It models beam width, intensity, and duration needed to produce 6EQJ5. The Very Large Array, VLA, uses Doppler drift modeling to analyze how Earth's rotation affects detection. It tests multiple beam sweeps for one-time events. Breakthrough Listen Initiative, machine learning scans trillions of channels in real time. It identifies potential anomalies matching the Gaussian profile of 6EQJ5. Simulations confirm that a highly directional, energy-efficient transmitter could have produced the WOW signal, but only if precisely aimed and timed.
Chapter 2. Follow-up Observations. Since 1977, multiple observatories have attempted to detect a repeat. Ohio State University's Big Year, before dismantling, repeated scans, no results. Arecibo Observatory, high-resolution targeted observations, no repetition. Very Large Array, narrowband surveys, no matches. Global SETI Network, monitoring of Chi Sagittarii and surrounding regions. Despite advanced instruments, 6EQJ5 remains singular, illustrating the challenges of detecting rare, transient interstellar signals. Chapter 3. Repeat Detection Strategies. Scientists have devised strategies to increase the likelihood of observing similar events. Continuous monitoring, multiple telescopes scanning the sky simultaneously. Global coordination, sharing real-time data to maximize coverage. AI-powered algorithms, detecting anomalies with Gaussian-like characteristics. Targeted observation windows, focusing on stars with potential habitable zones. These strategies represent humanity's long-term commitment to cosmic listening. Chapter 4. Technological Impact. The WOW signal has influenced modern astronomy and engineering. Data processing, stimulated development of high-throughput digital pipelines. Signal analysis algorithms, machine learning tools now scan enormous datasets. Narrowband detection, refined sensitivity for detecting extremely faint signals. International collaboration, networks coordinate observations across continents. Chapter 5. Cultural and Philosophical Influence. Beyond science, the WOW signal shaped human imagination. Media, featured in documentaries, books, and podcasts on extraterrestrial life. Art and literature, inspired stories exploring communication with other intelligences. Public engagement, sparked amateur astronomer clubs and skywatching communities. Educational outreach, demonstrates principles of physics, probability, and critical thinking. 6EQUJ5 symbolizes curiosity, wonder, and humanity's quest for cosmic connection. Chapter 6. Looking Forward. The WOW signal continues to guide SETI. Future telescopes, more sensitive and extensive sky coverage. AI and machine learning, improved algorithms for rare event detection. International networks, coordinated observations to avoid missed events. Long-term observation, preparing for intermittent or one-time signals.
Even after decades, the signal's influence endures, reminding humanity that the universe may still have messages for us. WOW Signal, Part 13. Physical Models, Source Systems, and Future Communication Technologies. The WOW signal, brief yet iconic, remains a beacon in SETI history. Understanding its potential origin requires exploring the physical technologies that could produce it, the stars it may have come from, and why it may never repeat. Chapter 1. Radio beacons versus laser beacons. Scientists theorize two primary interstellar signaling. Radio beacons. Narrowband directional transmissions at frequencies like 1420 MHz. Energy efficient over hundreds of light years. Gaussian profiles align with 6EQUJ5's characteristics. Practical for civilizations using conventional electromagnetic technology. Optical or laser beacons. Extremely narrow, high-intensity pulses. Require precise pointing to intersect Earth's position. Modern technology enables photometric detection, though in 1977 such instruments were not widely used. It could complement radio signals, forming a multi-channel detection strategy. Both methods demonstrate that advanced civilizations could engineer highly detectable signals, but their detection depends on alignment, timing, and instrument sensitivity.
Source: star systems. The WOW signal is believed to have originated near Chi Sagittarii, a multiple star system in Sagittarius. Distance: approximately 200 to 300 light-years from Earth. Composition includes giant stars and main sequence stars. Potential habitable zones, likely candidates for planets capable of supporting life. Other nearby systems have been considered as alternative sources, but Chi Sagittarii remains the most probable origin due to signal direction, lack of nearby terrestrial interference, and minimal dispersion effects from the interstellar medium. This localization guides targeted follow-up observations. Why the signal may not repeat. Despite decades of searching, 6EQJ5 has never repeated. Possible reasons include sweeping beam hypothesis. A rotating directional beam only intersected Earth briefly. Intermittent transmissions. Advanced civilizations may broadcast infrequently to conserve energy. Accidental or experimental burst. Transmission may have been a test, not intended to repeat. Destruction or relocation of source. Catastrophic stellar events or technological migration may have ended the signal. Timing and alignment. Beam may sweep across vast distances at intervals of decades or centuries. These factors explain why repeated detection remains elusive. Chapter 4. Future Communication Technologies. The WOW signal informs future interstellar communication. Next-generation radio arrays. Greater sensitivity, wider frequency coverage, and real-time anomaly detection. AI-powered analysis. Detects fleeting narrowband signals across multiple observatories. Laser communication. High-intensity, tightly focused optical beams as alternatives to radio. Global observation networks. Coordinated worldwide efforts improve chances of catching intermittent signals. 6EQJ5 demonstrates the need for precision, patience, and advanced technology in interstellar communication. Cultural and scientific legacy. Even without repetition, the WOW signal has left a lasting mark. Scientific. Set benchmarks for anomaly detection, narrowband scanning, and telescope design.
Cultural. Inspired media, literature, and public fascination with extraterrestrial life. Philosophical. Encourages reflection on humanity's place in the cosmos. The red-circled wow remains a symbol of curiosity and cosmic wonder, motivating scientists and dreamers alike. Chapter 6. Continuing the Search. Humanity continues the quest, monitoring Chi Sagittarii and similar star systems, employing advanced machine learning to detect rare signals, collaborating globally for real-time observation, developing technologies capable of identifying transient, narrowband, or multi-channel signals. The wow signal reminds us that even a fleeting cosmic whisper can spark decades of inquiry and perhaps, one day, a breakthrough discovery.
Decoding, algorithms, and humanity's cosmic perspective. Though the wow signal lasted only 72 seconds, it has inspired decades of computational, mathematical, and philosophical investigation. Understanding its possible content, even if symbolic, requires analysis beyond simple signal detection. Chapter 1. Mathematical and Probabilistic Analysis. 6EQJ5 represents signal intensity rather than semantic content, yet scientists have explored potential structures. Gaussian curve analysis. Signal conforms to a near-perfect Gaussian envelope, suggesting point source drift across telescope beam. Statistical modeling shows probability of such an event from random noise is near 1 in tens of millions. Numerical conversions. Letters converted to numeric values reveal smooth distributions. Attempts to find prime numbers, sequences, or mathematical patterns have been inconclusive. Probability models. Bayesian inference indicates very high likelihood of cosmic origin. Low likelihood of terrestrial or natural interference further supports engineered transmission hypothesis. Chapter 2. Coding and Information Theory. Researchers have speculated about encoded messages. Entropy analysis. Short single-event signal contains minimal information by Shannon metrics, consistent with a beacon rather than a complex message. Symbolic interpretation. Gaussian peak may act as attention grabber, signaling intelligent origin. It could serve as an introductory beacon, paving the way for future transmissions. Repetition and redundancy. A single pulse is insufficient to convey a full message. Future signals may include redundant coding, potentially recognizable to observers with minimal assumptions.
Modern SETI algorithms. Since the wow signal, SETI has implemented advanced computational techniques. Fast Fourier transform, FFT, detects narrow-band signals in large data sets, converts time domain data to frequency domain efficiently. Machine learning anomaly detection. Algorithms scan trillions of frequency channels for Gaussian-like transients. Helps identify rare one-time signals similar to 6EQJ5. Real-time cross-correlation. Multiple observatories compare signals instantaneously. Reduces false positives from terrestrial interference. Data archiving and mining. Historical data from decades of observation is scanned repeatedly. Allows retrospective detection of previously unnoticed signals. Chapter 5. Humanity's Philosophical Reflections. The wow signal prompts profound reflection. Cosmic perspective. Suggests that intelligence may exist elsewhere. Challenges human-centric assumptions about life and communication. Scientific patience.
A one-time signal illustrates the need for long-term observation and persistence. Ethical considerations. If signals are intentional, humanity must consider how to respond responsibly. Raises questions about broadcasting messages to unknown civilizations. Chapter 5. Technological and Cultural Impact. The WOW signal has influenced technology and culture. Instrumentation. Development of more sensitive radio arrays. Algorithms optimized for transient, narrowband detection. Media and literature. Inspires films, books, and documentaries exploring contact scenarios. Education. Case study in physics, probability, and computer science. Demonstrates real-world applications of signal processing. Societal imagination. Red-circled WOW became iconic for curiosity and exploration.
Future outlook. The WOW signal teaches lessons for future generations. Continuous observation. Signals may be brief or intermittent. Advanced AI analysis. Machine learning will continue refining detection. Global collaboration. Observatories worldwide increase the chance of detection. Cultural awareness. Humanity must prepare ethically, technologically, and philosophically for contact. 6EQUJ5 remains a symbol of human curiosity, cosmic exploration, and the potential for interstellar dialogue. Part 15. Evolutionary scenarios, reproduction models, and future SETI strategies. Extended, long-form documentary narration. The WOW signal, a brief cosmic anomaly, continues to challenge our imagination and scientific rigor. Exploring how an advanced civilization could create such a signal, and what this means for humanity, requires understanding evolutionary, physical, and strategic perspectives. Chapter 1. Evolutionary Scenarios for Intelligent Life. If the WOW signal originated from a civilization, what evolutionary path might they have taken? Single-planet civilizations likely focus on energy efficiency and resource management. Use narrowband, highly directed transmissions. Multi-planet or interstellar civilizations. Greater access to energy and mobility. Capable of galactic-scale communication networks. Post-biological or machine intelligence. Optimized for precision, long-term persistence, and energy-efficient signaling. Could maintain interstellar communications over millennia. These evolutionary scenarios help model the possible design choices for interstellar beacons. Chapter 2. Interstellar Communication Methods. Potential methods for transmitting signals like the WOW signal include directed radio transmissions, narrow frequency bandwidths aligned to habitable systems, Gaussian profiles consistent with big ear detection, optical or laser transmissions, extremely narrow, intense pulses, complementary to radio for dual-channel detection, hybrid or phased array systems, use multiple sources to increase coverage while conserving energy. Each method reflects trade-offs between energy, detectability, and alignment precision.
Physical and mathematical models. Modern scientists simulate the WOW signal using advanced computational models. Gaussian fitting models the signal's amplitude profile, confirms near-perfect bell-shaped intensity pattern. Beam propagation modeling calculates energy, alignment, and Doppler effects over light years, determines beam width and duration needed for detection. Noise in interference analysis distinguishes cosmic sources from terrestrial or instrumental noise, confirms the signal's unique properties.
These models demonstrate the plausibility of engineered interstellar beacons and guide modern SETI strategies. Chapter 4. Cultural and Technological Impact. Even decades later, the WOW signal continues to influence science and culture. Science and engineering, refined narrowband detection techniques, advanced algorithms for rare transient signals, culture and media, inspired documentaries, books, and science fiction. Red-circled WOW symbolizes curiosity, exploration, and the unknown. Education and public engagement demonstrates real-world applications of physics, probability, and computer science. Encourages participation in amateur astronomy and global observation initiatives. Chapter 5. Future SETI Strategies. The WOW signal informs long-term approaches to detecting extraterrestrial intelligence. Continuous global sky monitoring maximizes the likelihood of detecting one-time or intermittent signals. Advanced AI and machine learning identifies anomalies in real time across trillions of channels. Cross-observatory collaboration ensures rapid verification and reduces false positives. Targeted follow-up of promising star systems. Chi Sagittarii and similar systems remain key observation targets. These strategies aim to ensure humanity does not miss another 6EQJ5.
Psychological, philosophical, and long-term strategies. The WOW signal, though a brief anomaly, has rippled through human consciousness, science, and philosophy. Understanding its implications requires examining how humanity interprets and prepares for potential contact. Chapter 1. Psychological Impact. The 6EQJU5 signal evokes profound psychological responses. Curiosity and wonder. Inspires fascination with the cosmos. Encourages exploration, observation, and scientific inquiry. Existential reflection. Challenges assumptions about human uniqueness. Prompts contemplation of life beyond Earth. Speculative anxiety. Raises questions about potential threats or unknown intentions. Encourages careful consideration of responses to extraterrestrial signals. These responses illustrate that even a single 72-second signal can profoundly shape human thinking. Chapter 2. Philosophical Implications. The WOW signal provokes questions that span ethics, metaphysics, and cosmology. Anthropocentrism versus cosmic perspective. Reminds us that life may exist beyond Earth. Encourages humility in our understanding of intelligence and civilization. Ethics of contact. Should humanity respond to a potential signal? Could unverified responses cause harm or misunderstanding? The nature of communication. Signals may be fleeting, symbolic, or intentionally cryptic. Forces humans to reconsider assumptions about how intelligence conveys meaning.
Long-term strategies for interstellar communication. The WOW signal informs strategies for future contact. Continuous monitoring. Global observatories operating in coordination. Advanced AI and predictive algorithms. Detect rare, transient signals. Model possible repeat patterns based on beam sweep or intermittent transmissions. Signal verification protocols. Immediate cross-checking with other observatories. Prevents false alarms from terrestrial interference. Cautious response planning. Ethical guidelines for broadcasting messages to unknown civilizations. Consideration of long-term societal and ecological implications. Chapter 4. Simulation and Reproduction Analysis.
Scientists model the WOW signal to understand its properties and potential replication. Gaussian envelope simulation confirms bell-shaped amplitude pattern over 72 seconds, matches expectations for a point source moving across a fixed beam. Beam width and energy calculations. Narrow directional beams maximize detectability while conserving energy. Doppler drift analysis refines origin estimates. Hypothetical repetition modeling simulates intermittent transmission intervals from decades to centuries. Guides observational strategies for rare, one-time signals.
Humanity's cosmic perspective. The WOW signal compels reflection on our place in the universe. Connection to the cosmos. Even a brief signal connects humanity to potentially vast, intelligent networks. Scientific motivation. Drives innovation in telescopes, algorithms, and observational networks. Cultural and philosophical resonance. Inspires art, literature, and media exploring first contact scenarios. Long-term vision. Encourages sustained exploration and readiness for signals that may arrive once in a lifetime or over centuries. WOW signal, grand finale, the cosmic whisper and humanity's eternal quest. It was August 15, 1977. A fleeting moment, a cosmic whisper, traveled across hundreds of light years, cutting through the silent void, landing in the receiver of the Big Ear telescope. Jerry Ehrman circled 6EQJA5 in red ink, wrote "Wow," and unknowingly, humanity had been touched by something vast, mysterious, and perhaps intelligent. For decades, astronomers, mathematicians, and dreamers have tried to unravel the enigma. The signal never repeated, yet in that singular 72-second event, the universe seemed to lean closer, as if teasing us with the possibility of companions among the stars. The story of 6EQJA5. Imagine an advanced civilization, light years away. Perhaps they had learned the delicate art of communicating across the cosmic seas. Their signal, narrow and precise, sweeps across space like a lighthouse beam, momentarily brushing past our fragile blue planet. We were there to listen, by chance, by curiosity, by the unquenchable human desire to know. They may have sent it as a greeting, a test, a demonstration of intelligence, or perhaps we will never understand their intentions. The message lies not in words or codes, but in the experience itself. The knowledge that the universe is larger, stranger, and more magnificent than we can fully comprehend. The legacy of the signal. The WOW signal has taught humanity more than its scientific properties. That a single fleeting moment can change the trajectory of curiosity, technology, and imagination. That listening is as important as speaking. That mystery fuels growth, pushing us to innovate, to simulate, to explore. It has inspired generations to build telescopes, algorithms, and networks, reaching farther and deeper into the cosmic ocean than ever before. It has inspired artists to paint the stars, writers to imagine first contact, and philosophers to ponder life beyond Earth.
The human story. Every human who gazes at the night sky participates in a subtle conversation with the cosmos. 6EQJ5 reminds us that we are not merely observers, but listeners, seekers, and participants. Even in silence, even in absence, the universe speaks in whispers.
And in that whisper, we hear ourselves, our curiosity, our courage, our dreams. Perhaps one day the signal will return. Perhaps it will not. But in the waiting, humanity has already changed. We have learned to look beyond ourselves, to ask questions without expecting immediate answers, to imagine civilizations that might greet us across the stars. Epic closing thought. And so, as we continue to listen to the silent symphony of the universe, we realize this. The cosmos does not merely whisper to those who are ready. It transforms those who dare to listen. In that transformation, we are forever connected to the infinite, to the unknown, and to the eternal quest for understanding.